As you can see, this is a very long question. Altogether, it adds up to 13 marks. So let's unpack this question. So the function is defined by this rational function. So let's just have a look. What does it mean? How do we read that? We say function f such that, the columns are for such that, x is converted to this particular function. And so now we must find the inverse of that particular function. There are exactly 4 steps to do this. So firstly, replace that function with y. And so we will write y is equal to 3x plus 5 over x plus 1. Now try to swap the x's and the y's. So we'll start with x is equal to 3y plus 5 over y plus 1. And now we'll solve the equation for y. So I'll multiply x with the y plus 1. And that way I remove the denominator from the right hand side. Now I will expand. And I want to gather the y's together. So we have y on here, and we also have y on this side, right hand side. So we'll move them to the same side. And move the x to the other side. So we'll have 5 take away x. And factorize the left hand side for the y. And rearrange everything for y. Now, this can also be written as, if we multiply the denominator by a negative sign, we'll get a positive x plus 5 on the top, and we'll get 3 minus x. It's exactly the same thing. Lastly, we need to replace the y with the f to the minus 1, which means the inverse function. So the inverse function is now, and remember this step is going to give you a mark because this is what the question asks for, and there are 3 marks in here. I'll just add that we can swap this because some of the textbooks and instructions will swap those variables, and they say you can do step 3 before step 2. It doesn't really matter. If you're going to find the inverses that way, then make sure that you practice it enough to remember what the steps are. But whether you take step 2 or step 3 first is irrelevant. And now we come to the second part. And here we want to show that that composite function is x plus a over x minus 1 when x is a member of the reals and x cannot be positive or negative 1, because in here in the denominator, if we make this 1, then this will be 0. And a is an integer that we must find. And we were told, we already know that fx is 3x minus 5 over x plus 1. So if we want to find fx, then we will need to substitute we'll need to substitute this value here, 3x minus 5 over x plus 1. So every time I see x, I'm going to insert 3x minus 5 over x plus 1, and that's minus 5. Now I need to divide this over with x. So one more time, insert 3x minus 5x plus 1, and then I'll add x plus 1. Okay, now to simplify this, I'll multiply both sides by x plus 1 over x plus 1. And the reason I'm doing that is so that now I can delete all the denominators. And all my denominators are gone. And so I can rewrite this again. Well, now I'll try to expand this. That'll be 9x, and I won't use any more color, minus 15 minus 5x minus 5. And I'll lose the brackets over here, so it'll be just 3x minus 5 plus x plus 1. Now it's easy just to get all the terms together. 9x minus 5x is 4x, minus 15 minus 5 is minus 20 over 4x, and minus 5 plus 1 minus 4. And if I divide everything by 4, that'll give me x minus 5 over x minus 1, which means that a must be equal to minus 5, because they did ask you to find what a is, so you'll get a point for that. If you're wondering why it says x cannot be plus or minus 1, definitely in here x cannot be 1, because this whole thing will be 0 and we cannot have it. Also, if you look at in the original function, we've got x plus 1. If we made x equal to minus 1 over here, we would also not be able to have a function. It'll be undefined. All right, let's go on to the next problem. And we once again have a composite value over here, function that we need to solve. And this time we've got a function g such that x is converted to this function over here. So we know that the function g is this. And the x values are real, but they must stay within the boundary of 0 and 5. And we also know that fx is equal to, firstly, let's have a look what g2 is, which will be 4 minus 6, and that'll be a negative 2. So this negative 2 now, we'll need to insert it into this x. Minus 1, and that's minus 11 over minus 1, which is 11. And that's the answer. Let's just put it down here properly. 2 more questions to do, but this one is worth 3 marks, and we have to find a range of g. You should take note of the fact that we had here certain constrictions on x value. All right, so g of x, I hope that you can recognize this one, x squared. What does it tell you straight away? That it's going to be a quadratic. And we only need it between 0 and 5. So there's not too many points. This is one where I would just sketch it. With 0 to 5. 0, 1, 2, 3, 4, 5. I'll just fill them in myself. That'll be just 0. And I calculated all the rest and also tried to graph them over here. And as I said, this is going to be a parabola, because this is a quadratic. And it looks as if it's going to go from 10 to down here and up here, and I can see that it's going to come down here, and I've got 0, 0 and minus 2, which means that it will have its minimum somewhere around here and start coming back again. Now we're looking for the range, so it'll be in the y-axis, and we'll need to go all the way down to this part over here, which is the minimum. And so we will need to look for this y value over here, which is here. So how do we find the minimum? I guess there's many ways, but the way I would do it is by having a look and saying, well, this is 2 and 2, and this is 0 and 0, minus 2 and minus 2, which means that if it's symmetrical, that means that our x value must be somewhere here, which will be 1.5. So if we put 1.5 into our function, g function, and say 1.5, and 1.5 into it will be 1.5 squared minus 3 times 1.5, and I should get minus 2.25. I've used a calculator, and so the lowest point over here will be minus 2.25. So the range of gx is minus 2.25, which is equal to and less than. Now remember, this is going to be very important that you actually put gx over here, because we are talking about the range. If you just put x, you'll lose marks, because we are talking about the y values, not the x values. And lastly, just the last question, which is worth 1. And the answer to this is quite simple, but let me explain it to you, what it actually means. Well, we've got the question here is, y is the function g. So you need to know what the definition of a function is. Let me just draw that function for you that we'd had. Remember, you don't have to draw that. I'm just explaining to you. Right? This was your gx function. Now to find the inverse, we have to do a reflection in the x equal y axis. So if I try to do a reflection, my inverse would look like this. Now, one of the things we need to know is the definition of a function. A function is not the same thing as a relation. A function must be a one-to-one. That means that the input must have only one output. Whereas in a relation, you can have two outputs. Say, for instance, if I look at my relation, if I look at x is equal to 1, for instance, where I've got this, you can see that there are two values of y, and therefore it is not a function. And this is all you need to do right for this 1 mark. Gx is not a one-to-one function, therefore it does not have an inverse. I hope that was really useful to you. Please subscribe to my channel and also give me a thumbs up.